Hi students, welcome on the channel. This time with DK Swami. So in today's lecture, we will discuss the JEE Advanced 2025 paper which is conducted today. I just got the paper right now. So one by one, I will be uploading the solution for this question paper. This is the first question of this paper one, where we have been given this a ring, and at the center of the disk of radius r and the mass m is attached to a spring of constant k inside the ring. Okay, so the information given to us is that this is a disk of radius r and the mass m is attached to a spring constant k inside the ring. Radius is of this one is greater than r. The other end of the spring is attached to the periphery of the ring. Both the ring and the disk are in the same vertical plane. Okay, and the disc can only roll along the inside periphery of the ring without slipping, so it means it is a pure rolling condition. And the spring can only be stretched and compressed along the periphery of the ring. Okay, so what is that is, like, if it is going to perform the motion something like that, then this spring is going to stretch like this. It is not going to stretch something like that. Okay, it is like not a straight line, it is along the periphery. Following the Hooke's law, in the equilibrium, the disk is at the bottom of ring. Assuming a small displacement of the disk, the time period of oscillation of the center of mass of the disk is this much, then the correct expression for the omega. So I just did solve this question using the energy method like this. That okay, let us take that at some point it is moving with a velocity v like that, and with the angular velocity omega. Okay, and at that point it is having some height h from the ground, and there is a extension x in this spring. So because it is a SHM, and in the SHM the total energy is conserved, so I can say that the half mv square plus half I omega square, which is the total energy of the rotational plus translation motion, plus the potential energy mgh plus half kx square becomes equals to constant. This is the energy method for the calculation of the omega for any SHM, right? Now what I'm doing is I'm differentiating this. So I'm writing down half, and then the m, and the v differentiation is 2v dv by dt half I, and the omega differentiation is 2 omega d omega by dt, and then we have mg, and dh by the h differentiation is dh by dt half k, and then the x square differentiation is 2x dx by dt, and constant differentiation becomes 0. Okay, so now from here we need to form a equation something like this: a equals to minus of omega square x. Okay, if I want to form this kind of equation, for that I will, one side I should have dv by dt, which is the acceleration, the other side I should have the x displacement from the mean position. So I have mv and dv by dt, and then this side the moment of inertia. This moment of inertia is about the center of mass, which is mr square divided by 2, and the omega, because it is rotating, it is doing the pure rolling, so we will have v equals to omega small r. Okay, that is the relation. So that's why omega can be replaced by v divided by r, and the d omega by dt is basically dv by dt divided by r, according to the same relation. Okay, and then we have mg, and here a bit we need to do this carefully. So what is happening is, from the center of mass distance is r minus r. Okay, why? Because this complete distance is r, and the center of mass distance is small r, so that's why the center's distance from this is r minus r, and I'm displacing x like this, then it is covering a theta angle, right? Okay, now what I can say is the height covered like this. Okay, let's suppose it is moving with v velocity. Okay, let me, so it is moving with v velocity like this, then the component of velocity in the upward direction is going to be v sine theta, because this angle is theta something, so v sine theta like this. And because theta is very small, so that's why the velocity becomes the v theta in the upward direction, so that's why dh by dt becomes v times of theta. And what is theta? Theta is this, theta is length of arc, which is x divided by r minus r. Okay, so x we can replace like this, and yeah, so x we can replace. So when we are writing here, the differentiation of half kx square is k times of 2x dx by dt. Okay, so here what I have done is I have and the ds by dt I have replaced like this. Ds by dt is v times of theta is x divided by r minus r. Okay, from here dx by dt is basically v, so I have cancelled out all the v's. Then I have a equation this side, dv by dt is acceleration a, and here also dv by dt, so acceleration a, right? And this is m mass, so m mass, and this is m by 2, so that's why m by 2, and the r square is cancelled out. Okay, so m plus m by 2 is equals to a, m plus m by 2 times of a, sorry. And this side, we if we take these two terms that side, because it is equals to 0 complete, so that's why that becomes negative, and this will have mg divided by r minus r plus k, and times of from here and here we can take out x common, and from here acceleration we can write it as mg, this acceleration term is this term divided by this term, and then from there we can compare it with the standard equation of the SSM, a equals to minus of omega square x. So if we compare this, this becomes the omega. Okay, this becomes the omega, so then the omega answer comes out to be this, which is the first option. So according to me, first option is correct. Still there may be some calculation error because of me, so you can also check the other solutions. Thank you.